Hello guys, welcome back to my YouTube channel. I'm Prakriti and from CSEI. So today I'm going to present about clustering, which comes under the subject called Advanced AI&ML. Clustering patterns in data. Welcome to this exploration of clustering, a powerful data analysis technique for grouping similar data points into meaningful clusters. So this presentation will introduce you to the fundamentals of clustering, delve into various algorithms and guide you through evaluating their performance. So we will also touch upon the importance of dimensionality reduction in optimizing the clustering process. Join me as we uncover the fascinating world of clustering and learn how it can reveal hidden patterns and insights from your data. What is clustering? So, unsupervised learning. Clustering falls under unsupervised learning, meaning it doesn't require labeled data. It discovers hidden patterns and structures within the data without prior knowledge of the groups. Think of it as finding the natural groupings within a data set. Grouping similar data. So, clustering aims to group similar data points together based on their characteristics. So, these characteristics can be anything from customer demographics to product features, allowing you to segment data based on similarities. The importance of clustering. Customer segmentation. Divide customers into distinct groups based on their purchasing habits, demographics, or preferences. So this allows targeted marketing and personalized experiences. Anomaly detection. Identify unusual data points that deviate significantly from the rest of the data. So these anomalies can indicate fraud, system errors, or other important events. Image segmentation. Group pixels in an image based on their color, texture, or other visual features. So this can be used for image recognition, other detection, and image compression. Pattern discovery. Uncover hidden patterns and relationships in large data sets, providing insights that might not be easily observable otherwise. This can be used for scientific discovery, market research, and more. Types of clustering algorithms: partitioning, hierarchical, density based, and model based. Partitioning, K means K, medoids, and fuzzy C means fall under partitioning algorithms. They partition the data points into a predefined number of clusters. Hierarchical algorithms create a nested structure of clusters. They can be agglomerative, bottom up, or top down. Density based. So DB scan optics and DenClue are density based algorithm that clusters data points based on their density. They are good for identifying clusters of varying shapes. Model based algorithms and assume a probability distribution for each cluster and estimate parameters to fit the data to the model. K-means clustering, iterative algorithm. So K-means is an iterative algorithm that starts with an initial set of centroids and repeatedly assigns data points to the closest centroid, recalculating the centroids based on assigned points. Predefined number of clusters, so you need to specify the number of clusters k before running the algorithm. Choosing the optimal k is crucial for accurate clustering. So k-means typically uses Euclidean distance to measure the similarity between data points and centroids. Hierarchical clustering, agglomerative starts with each data point as a separate cluster. It iteratively merges the closest clusters until a single cluster is formed. Divisive starts with all data points in a single cluster. It iteratively divides the cluster into smaller clusters until each data point is in its own cluster. Dendrogram, the result are visualized in a dendrogram, a tree-like diagram showing the hierarchical of clusters. So DB scan clustering, so that is a density-based approach. Clustering of applications with noise identifies clusters by finding areas of high density in the data. Core points, data points with a minimum number of neighbors within a specified radius are considered core points. So these form the center of clusters. Outlier detection. DBs can effectively identify its outliers or noise points which don't belong to any cluster. Choosing the right clustering algorithm. So data structure, consider the shape, size and density of clusters in your data. Some algorithms are more suited to specific data structures. Outlier sensitivity assesses how much your data contains outliers. So some algorithms are more sensitive to noise than others. Performance requirements, consider the size of your data set and computational complexity of different algorithms to ensure efficient performance. Business goals, align your choice of algorithm with your specific business objectives such as customer segmentation or anomaly detection. Clustering evaluation metrics. So measures how similar a data point is to its own cluster compared to other clusters. A score closer to 1 indicates good clustering. Measures the role in done index that measures the ratio of the minimum inter-cluster distance to the maximum intra-cluster distance. A higher done index implies better separation of clusters. So evaluates the ratio of between cluster variations to within cluster variance. So a higher value indicates a better separation of clusters. Dimensionality reduction for clustering. So high dimension clustering in high dimensional species can be compensationally expensive and prone to noise. So improved performance, dimensionality reduction can lead to faster clustering algorithms and improve the accuracy of clusters. Thank you.